Okay, guys, we're going over the review sheet. If there's a question you wanted to jump to, you can always just fast forward into the video to find that question. Olivia visited the art supply store to purchase supplies, spending a total of $42. She bought 5 more markers and paintbrushes and 3 fewer crayons and paintbrushes. Paintbrushes are at $1.80 each, markers were priced at $2.50 each, and crayons at $4 each. If X represents the number of paintbrushes that Olivia bought, write an equation in terms of X that can be used to find how many of each item she bought. So I know they want us to write an equation in terms of X. That's what we are trying to do. And if I'm going to go back, I'm going to underline some important, let's underline it and figure out what each values are. So I have $42, and that is a total of $42. That's how much she spends in the art store. Another value I see is $1.80 each, and that is the price for the paintbrushes. Markers are priced at $2.50 each, right there, and crayons were priced at $4. There we go. Then there's something else that is also important. She bought 5 more markers than paintbrushes. Sorry, she bought 5. No, that's correct. 5 more markers than paintbrushes and 3 fewer crayons than paintbrushes. So that's all of my information. Let's see if we can put this together. If I know that paintbrushes, oh, one other thing is that X represents the number of paintbrushes. So I want to put an equation together that represents the price of everything. So let's see if we could put the price together of the individual items. If paintbrushes are $1.80 each, and X is the number of paintbrushes, then for every paintbrush I buy, we have to pay $1.80. So $1.80 X. This will represent the cost of the paintbrushes. Plus, well, now we want to figure out if for the amount of markers. Here's the thing, we don't have a variable for markers, but for the time being, let's see if we can create one. Let's say markers is represented by M. We could say M is the number of markers. Remember, anytime you create a variable, you gotta write what it represents. M is the number of markers, and let's do one for C, is the number of crayons. Good. So markers were $2.50 each. So we're gonna do 2.50 times the number of markers, which is M. And this here represents the cost of markers, plus, let's do the cost of crayons. They're $4 each, and then we're going to do 4 times the number of crayons, which would be C. And this here is the cost of crayons. So if I take the cost of the paintbrushes and I add them to the cost of the markers and the cost of the crayons and I add them all together, we've spent a total of $42. So this is an equation. The thing is, though, the equation isn't written in just terms of X. So we have to go back and look at some other information. She bought 5 more markers than paintbrushes. Well, when I see the word more, I'm thinking of an operation. What operation do you think of? Addition. So if X is the number of paintbrushes, we're told that X is the number of paintbrushes, and she bought 5 more than the paintbrushes, then we can say the markers are equal to the number of paintbrushes, which is X, plus 5. So she bought 2 paintbrushes, then she bought 7 markers. If she bought 3 paintbrushes, she bought 8 markers. Now let's see on the right side, they said she also bought 3 fewer crayons than paintbrushes. Now we have another word here, fewer. What operation do you think of if it's fewer, or you hear the word fewer, and that is subtraction? So if paintbrushes, let's say I bought 5 paintbrushes, or she bought 5 paintbrushes, then 3 fewer would be 2 crayons. Or if she bought 10 paintbrushes, 3 fewer would be 7 crayons. So an equation for that could be C is equal to X, the number of paintbrushes, minus 3. So any number of paintbrushes she bought, 3 less than that would be the number of crayons. Now, how can we use this in this equation? Well, we know we can have 1.80x is the cost of our paintbrushes plus $2.50 M, which is the cost of the markers, but instead of M, I can substitute this value of x plus 5. So here would be x plus 5 plus 4 times the number of crayons, which we have here, or the cost of crayons, which is x minus 3. The number of crayons times 4 would be the cost of the crayons. And altogether, this equals $42. And this here is the equation for the first part. You have the different values. If you add them all up and they multiply together, they'll give you a total of $42. Now the second part says use your equation to determine algebraically, that's an important word right there, how many paintbrushes Olivia purchased. So we're starting with the same equation, and when they say algebraically, they mean that they want you guys to simplify and use um, inverse operations in order to find that value of x. 250 times x plus 5 plus 4 times x minus 3 equals 42. What I just did is I rewrote the equation that we just came up with, which is the same one from on top here. We do 1.80x plus 2.50 times x plus 5. We're going to distribute 2.50 times x is 2.50x. And then 2.50 times 5, if you want to do it in the calculator, you can. This here will give us 12.50. Plus, we're going to distribute here as well. 4 times x is 4. And 4 times negative 3 is negative 12 equals 42. Whoop, no, 4 times x is 4x. Thank you guys for who caught that. And on the right side, it is equal to 42, not 92. There we go, 42. And now we're going to combine some like terms. I have a like term here, a like term here, and a like term over here. And then we have 1.80 plus 2.50 plus 4. And if you add those three together, you'll get 8.30x or 8.3x is also okay. 8.3x. And then we also have some more like terms, 1250 and negative 12. So we're going to combine those together. And when you combine those together, you get plus 0.50. It became 1250 minus 12 equals, and bring that up 42. Now we're going to do inverse operations, minus 0.50 to both sides. This will cancel out. You have 8.3x is equal to 41.50. And then you divide by 8.3 to both sides. X is equal to 5. And to put this in a statement or a sentence, the number of paintbrushes she bought was 5. And if she bought 5 paintbrushes, that means she bought 10 markers, and that means she bought 7 crayons. All right, moving on to number 2. Similar question. At an HBO marathon, Alex decides to buy some snacks and spent $12. He purchased 5 more bags of popcorn than cans of soda, and 3 fewer boxes of candy than cans of soda. Cans of soda were $2.50 each, bags of popcorn were $3 each, and boxes of candy costed $4.25 each. If X represents the number of cans of sodas Alex bought, write an equation in terms of X that can be used to find the number or how many of each item was bought. So what we can do here is we have X again. It's a very similar problem. It represents the number of cans of soda Alex bought. So X is the number of sodas. Number of sodas. Okay. Um, he spent $12 in total. He bought 5 more bags of popcorn than cans of soda, so that is similar to the last one. The cans of soda is X. 5 more means addition. So this is X plus 5. And if I want to make that popcorn, let's make popcorn P, a number of popcorn, and the boxes of candy C. So the popcorn, or the number of popcorn, is equal to X plus 5. And 3 fewer boxes of candy than cans of soda. So the fewer indicates subtraction. Uh, and then we have the cans of soda again, which is X. So, and 3 fewer of that. So we're going to say C is the number of candy, which is X, sorry, the number of cans, which is X, minus 3. Now let's put this together. Um, cans of soda are $2.50 each. Bags of popcorn are $3 each. And boxes of candy are $4.25 each. So it was to create what the cost, $2.50. Sorry, I think my mic disconnected. $2.50 for cans of soda. X. This is the cost of the amount of sodas you bought. Plus, there is $3 for the popcorn. So we're going to say $3 per popcorn, so 3p, plus $4.25 times the number of candy for each box that you bought. And in total, you spent $12. But now, again, they want it just in terms of X. So we know that we have here, we have C is X minus 3. C is X minus 3. And P is X plus 5. So what we're going to do is we're going to use this information to uh, substitute the values in so we have an equation with just the value of X. So let's bring down the 2.50 is going to stay the same. 2.50x plus 3 times p. But instead of p, we're going to put x plus 5. That's from over here. Oop. X plus 5 plus 4.25 times c, which is over here. Oops. Instead of c, we're going to put times x minus 3 equals 12. And right there is our equation. Now we're going to use this equation to determine algebraically how much candy was bought. 2.50x plus 3 times x plus 5 plus 4.25 times x minus 3 equals 12. Now we just simplify and solve. 2.50x stays the same, plus 3 times x plus 5, we're going to distribute 3 times x is 3x. 3 times 5 is positive 15, so plus 15. Plus the 4.25 times x is 4.25x. 4.25 times negative 3 is, if you need it, you do in your calculator, 4.25 times negative 3 is negative 12.75 equals 12. Now let's keep going. We're going to solve. We're going to combine our like terms. So our like terms, we have 2.5x plus 3x and plus 4.25x. 2.5 plus 3 is 5.5 plus 4.25 is 9.75. So this here becomes 9.75x plus 15 minus 12.75. That's going to give us 2.25. And it's a positive. Plus 2.25 equals 12. Now we're going to do inverse operations. Subtract 2.25 to both sides. That's going to give us 9.75 is equal to 9.75x. And then divide 9.75 to both sides. And the value of x is equal to 1. So this is saying, what was x? X is the number of cans. What's his name? Alex bought 1 can of soda. Okay, coming on down. We're going to solve an inequality. So when you're solving an inequality, it's the same thing like solving an equation. They're just one step that could be different. So if you're comfortable, you can rewrite it with an equal sign, or just remember, pretend there's an equal sign there. And if you want, we also can draw a line down the middle. Let me draw a very light line. We'll draw a line down the middle to indicate which is the two sides of our inequality. So here's the line. And we're going to start doing inverse operations. So we want to get all the x's to one side, and we want to get all the terms to the other. So I'm going to add 0.8x to both sides, so I can get all the x's together, which do to one side, you must do to the other. 1.5 and 0. So this side cancels out. On this side, you're going to get 2.3x. That's a positive, so plus, and then bring down everything else. 2,470 is, yeah, sorry. Bring down the 5,000, and we currently have 5,000 is greater than 2,470 minus 2.3x. Now, I got all of my x's to the right side, so I want to get all of my constants to the left. So I'm going to subtract the 2,470 to get it to the left side. So subtract 2,470 to both sides. and you do 5,000 minus 2,470, and you get 2,530, and then is greater than 2.3x. You can divide now to get x by itself. We're going to divide 2.3 to both sides. And when you divide this by 2.3, you get 1,100 is greater than x. The question is, but many people ask is, do we flip the sign here? We do not flip the sign because we divided by positive 2.3 to both sides, not a negative. But one thing we can do is, if you got it and the variables on the right side, to make it more comfortable to read, if you prefer, you can flip everything around so the variables on the left. This is the same as saying x is less than 1,100. So the solution is all values or all numbers less than 1,100. Okay, guys, we're going back to Unit 1 a little bit on this one. The table below displays the population in millions of 20 cities that voted on the East Coast. There's a bunch of values in this table, and you're asked to find the mean of the data and find the median. So there's two ways we can do this. We can do this by hand, or we can do it by the calculator. If you're doing it by hand, what you're going to do is you're going to add all these values together with each other. And once you add everything together, you're going to take the average. Remember, mean is another word for average. You're going to take the average by dividing by the number of values that we had. So if you take a look here, we had on this chart uh, 3 rows by 1, 2, 3, 4, 5, 6 columns. That means, so it's 3 by 6 columns. That means that there's 18 numbers in total. So we have 18 values. So you're going to add all of these together, and then you're going to divide it. So let's do this quickly. You can take the calculator to do this. We're going to do 2.0 is the same as 2 plus 2.2 plus 2.5 plus 2.7 plus 3 plus 3.2 plus 3.5 plus 3.7 plus 4 plus 4.2 plus 4.5 plus 4.7 plus 5 plus 5.2 plus 5.5 plus 5.7 plus 6.2 plus 6.5. And then you take that and all together. If I did not make a mistake in my entering, then I should have gotten about 74.3. And you take that value and divide it by 18. So the mean, or the average, should be about 4.2. 4.12. 4.12, or we can round this up to it's 4.123, so we can round it to approximately, oh no, it's 4.127. So we can round it up to 4.13. And that there is your mean. Okay. And to find the median, what you would do is you would cross out from when the numbers are in order. That is very important. And you just keep crossing out until you get to the middle. If there are two numbers in the middle, which will be true anytime you have an even set of numbers, you have to take the average of these two numbers. So 40 plus 41, and then that is 81. You divide it by 2. That's not 41. It's 40 plus 42, and you divide it by 2, and it'll give you the mean of 41, or the median, or the middle number of 41. Now there's another way to do this, if you guys remember with the calculator. And what you would do is you go to Stat, you go to Edit, and you're going to put all these values in, which is actually what we're going to do right now. let me clear up so I don't put in the wrong numbers. Where's my eraser? There. And what you're going to do is you're going to actually put all the values into the calculator, and we're going to find the statistics of it all together. So 2.0, enter. 2.2, whoops, what did I do? 2.2, enter. 2.5, enter. 2.7, enter. 3.0, enter. 3.2. And when you do a calculator, you actually don't have to put it in order, but you're going to do it by hand. If you find a median, you absolutely want the values in order. 5.7, 6.2, oh, that's 62, okay. Oh, please. 6.2, 6.5. Okay, and then to check the mean and median, you click Stat, you go over to Calc, and we're doing a one variable statistic. You press enter, and you'll get right here, which we got the mean of 4.12, which we rounded to 4.13. And then the median, if you scroll down, is 4.1, which is what we had as well. I just realized my point didn't show. So 4.1. Okay, so now they're asking, find the mean of the data with 7 million people. So now they're saying that another population was added in. So we have another value of 7, because these are all actually already in millions. So 7 was added, and how does that change the data? So what's the new mean? The new mean, so we'll go back to our stat actually. We're going to do this in the calculator. If I press edit and I go all the way down, I can actually just add another value in. Press 7, enter. And now the new value's in. Now let's go calculate our new statistics. Go over to stat, hit calc, go to one variable statistic, enter. Now our new mean is, the new mean is 4.278, which I'm going to round to approximately 4.28. So the mean increased. Find the new median. So let's scroll all the way down, and the new median is 4.2. So in this example, the median also went up. Did the mean or median change when the new 7 million people were added? Yes. Yes. The mean and median both increased. Okay. It may not always be the case. Sometimes the mean, well, actually, the mean would absolutely change because you had a value that's greater than all the values. Or if it was significantly lower, it would also change. But the median could stay the same depending on like how many of the same numbers show up in the middle. So please be analytical about that. All right, guys, we're down to the last question. Create a box plot of this data. So if you don't remember how to do a box plot, we're going to do it together. We're actually going to find the 5-number summary. We need to find the 5-number summary in order to do this. 5-number summary. And that is, we need to find the minimum, the first quartile, the median, the third quartile, and the maximum value. So the minimum, what we're going to do is actually we're going to use the calculator to calculate this. We're going to go to Stat, we're going to go to Edit, we're going to clear the whole list, go up, press Clear, then press Enter, and the whole thing clears. And we're going to put the values in. This also could be done by hand, but right now we're just going to do it with the calculator. We're going to put the values in 28, 35, 38, 42, 45, 46, 48, 49, 50, and 55. Okay. Once you have the calculator, in the calculator, go back to stat. We're going to the same place. We're going over to calc. Click on one variable statistics, and here is our data. We're going to scroll all the way down. I'll scroll all the way down. Uh, and it says our n is 10, so that means we put in 10 numbers. Let's double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Awesome, we have 10 numbers. The minimum value, which also we can see here is the smallest value, is 28. The maximum value is 55. The median value, so it's an even amount of numbers, so that means the median value is between here to here, was 45.5. And that's right here. 45.5. Now the first quartile was 38, meaning if you found the middle number between the minimum and the median, that would give us right here 38. This is your first quartile. And our third quartile is the middle number between the median and the maximum. It won't be this one, not this one, not this one. And that one there is 49. This is your third quartile. So in order to do the box plot, what I recommend you do is find these values on the line. The first one is 28. If I notice here, actually the number line goes from 0 to 20, but it's increasing by 4 units. So 4, 8, 12, 16, 20. If it helps you to write them in, you can also write them in. 4, 8, 12, 16, 20, and then it keeps going on up. So 28 will be so this is 20, 24, this is 28 right here. I'm going to put a line on 28. That's going to be my minimum. The first quartile is 38. So I'm going to put a line on 38. If this is 28, this is 32, this is 36, 38 is going to be right about here. Then I'm going to put a line on the median at 45.5. We're making an approximate guess because we have intervals of 4. So if this is 40, this is 44, and after 44, this is 48. So it's going to be somewhere in between, probably closer to 44, right about here. Our third quartile is 49. So this is 44, this is 48, so 49 is going to be right here. And our maximum is 55, which is going to be a little below this one right here. So once you have the 5 lines, you're going to connect the middle 3 and make a box around them. And then connect a line from the minimum and a line to the maximum. And this here is your box plot, where your minimum, your first quartile, your median, your third quartile, and your maximum. Awesome, guys. If you have any questions, please comment below. Maybe a classmate can help you out, or send me an email. I'll give it a shot. All right, guys. Have a great day. I'll see you guys for the uh, review exam, the mock Regents exam on Monday. Have a great day.